Welcome back, quantitative skills fans. Today we're going to be working with units of measurement and see how we can involve those to build to some solutions with our problem solving skills. So we're going to begin with an example. Coco's doing some landscaping in his front yard to add some curb appeal to his place. Suppose Coco wishes to cover a 5 feet by 100 feet rectangular area with cocoa bean mulch 6 inches deep. The landscaping company selling cocoa bean mulch only sells the mulch by the cubic yard. How many cubic yards must Coco purchase to cover the rectangular area with the prescribed depth? So what's actually going on here is we need to start looking at things of the nature we're talking cubic yards. So what sort of relationships does that have to? We see feet, we see inches. What do we have to build? And as soon as we can do that, we're going to be in great shape. But before we can get there, we need a little bit of information. And so that's what we're going to actually look at first, is how these things relate, distance and area and volumes and all that. So we'll begin with distance. The distances that you're probably familiar with are inches, feet, miles, kilometers, meters, centimeters, so on and so forth. And so you can have anything in that list appear, and we have some form of measurement that's a distance. And to build that to two dimensions, all we do is we square whatever we have, and we call it square inches, or you write inches squared, so you'll see the exponent appearing up there, or feet squared, or square miles, where you see miles squared, square kilometers, square meters, square centimeters, so on and so forth. Moving into volumes, you're basically cubing everything. So you get cubic inches, where we'll see in inches with a cube as the exponent, cubic feet, cubic miles, cubic kilometers, cubic meters, cubic centimeters. And so for volume, we're talking about how much space things take up in a three-dimensional sort of situation. And so some of the questions that we have are things like, how many square feet are in a square yard? And what most people will say is, oh, this is going to be pretty easy. It's got to be, there's 3 feet in a yard, so it's going to be 3 square feet in 1 square yard. And that's actually not the case, and I'll kind of explain why. As you can see the box right down here, we have 1 yard and 1 yard on each side if we're talking 1 square yard. And so we know that 1 yard equals 3 feet. So the beautiful thing is that we can break up each yard here into 3 different sections, and then we'll kind of draw in the cross sections all the way across. And so let's see. Well, when we start filling in this box here, notice we have a square foot. Each of these boxes, it's 1 foot by 1 foot, so meaning it's 1 square feet. So how many boxes do we have altogether? Well, we end up having 9 boxes. So what that means is that 1 square yard actually equals 9 square feet. But that's not the only way we could have gotten this. And what will serve us a lot better later on will be this other method where we can take 1 square yard. And so notice we have a square, so that means we need 2 yards in the denominators. And what we want to compare those to are feet, right? Because we want to convert it to square feet. So we know 1 yard is 3 feet. And so we'll put in all those feet there, and then so what we have is the yards will cancel. You'll have that square cancel with the 1 yard, and then the other yard, you'll see the line in the other direction here. So what happens is we get 1 times 3 times 3, and then feet times feet is feet squared, or square feet. And so that means we have 9 square feet in our answer. And we can use this method to kind of build towards cubic feet in a cubic yard. You can start with 1 cubic yard. And now all we'll do is we'll just multiply that. Well, we have to do conversions where we have 3 yards appearing in the denominators to cancel off of that yards cubed. So that means we have feet, feet, and feet to convert it to cubic feet. That means there's 3 feet, 3 feet, and 3 feet. So all of a sudden we have 1 times 3 times 3 times 3 cubic feet, or just 27 cubic feet, which a common answer once again on that one is happens to be people say just 3 cubic feet, which is not the case. It's 27 cubic feet. So basically we're taking that number 3, and if it's square feet, we're going to square the 3. If it's cubic feet, we're going to cube the 3. And so if there was a 4th dimension, we'd basically take 3 to the 4th to figure out what happened there. Don't worry about the 4th dimension though, by the way, but just that's a mathematical thing that we get into. So another method for doing this goes back to what we just began with. You can actually draw out the cube, and you have a 1 yard by 1 yard by 1 yard cube, and then we could divide it into subsections. So you know that each one of those you have 3 feet, and so all of a sudden we can start to take a look at this. And each little block, and so I'll shade one in right here, So you can see that block at the top right corner. We're going to count each of those because that's one cubic foot. How many blocks exist? And you could pretend it's cubes of cheese or something like that. Well, if you broke it apart piece by piece, you could just see on the front face you're going to have 9 blocks. And then you'll have a second ring as you move back, right? Because you've taken up the whole thing. So as you move back a little bit further, you'll have a second ring of 9 and then a third ring of 9 at the very back end of this cube. So that gives us 27 cubic feet. So 2 different ways to kind of see this. And what this allows us to do, though, is we can use this information to kind of build towards an answer of our first example. And so what we need, notice we're talking cubic yards, so we're going to need some sort of volume. And so the problem solving skill, we're going to need, okay, to calculate volume of how much mulch we're going to spread. And so in order to do that, we have some rectangular shape. And remember, like rectangular solids have length times width times height. And in our case, our length is 5 feet, our width is 100 feet, and then our height is 6 inches, right? But there's a problem there is the inches, we need that to be in feet because we need all measurements to be the same. So we got to convert that. Well, you know, there's 12 inches in 1 foot, so that means the inches has to go down in the denominator and the 1 foot goes in the numerator, so you get 6 over 12 feet, which is a half a foot. So we can erase that 6 inches and put in a half a foot. So what does that mean? Well, now we just multiply all those because you have your length, you have your width, you have your height. And so 5 times 100 times 1 half, and this will be cubic feet. So that should be 500 times 1 half, 500 divided by 2 is 250 cubic feet. Okay, so that seems hunky-dory. Now what do we have to do? Well, we need to figure out how many cubic yards must Coco purchase. Well, we know that 1 cubic yard happens to be 27 cubic feet. We just made that calculation. So moving forward from there, what can we do? Well, we can take the 250 cubic feet and we want to figure out how many cubic yards it is. So we have cubic feet down below, we put cubic yards up top, and we know there's 27 cubic feet in 1 cubic yard. So that means our calculation is just going to be 250 divided by 27, because the cubic feet is canceled, and that should be our cubic yards. And this is approximately, if you punch it into a calculator, 9.259. But when you think about this, Coco can't purchase 0.259 cubic yards. When you go to buy something, if it's only sold by the cubic yard, you must buy it to the round up for a cubic yard if you need to cover it. So in order for Coco to cover the front yard, Coco must purchase 10 cubic yards of cocoa bean mulch. So hopefully that makes sense with the problem solving there and tossing that in, and along with the measurements, needing those measurements. So let's kind of tie in one. We've done one with volume. Let's try one with area in this case. So let's say Chandler wants to buy a home in Pooler, and the average home in the area sells for around $120 per square foot. The home Chandler wants to buy has 2 bedrooms that are 20 feet by 10 feet, a master bedroom and bathroom that are combined 20 feet by 30 feet, a bathroom that is 10 feet by 5 feet, and a kitchen leading into a great room that is combined 40 feet by 30 feet. If the home is listed for $247,300, does Chandler have a better than average or a below average deal with that home? So the key here is just finding total square footage, right? That's what it's going to come down to. So you have the first bedroom, and remember there's 2 of them right out the gate. So we can figure out the area. We know the first bedroom is 20 feet by 10 feet. And if you have a rectangular room, essentially you're looking at the length times the width. And that's what we're going to assume just by when you see that by right there. It's telling you rectangular in nature. So we have 20 feet by 10 feet, that's 200 square feet. And the second bedroom is exactly the same, it's 200 square feet. Okay, so now we've taken care of that first term, and we'll underline that there. So now moving on to the master bedroom and bath, we know that's 20 feet by 30 feet, and so if you multiply those two, you get 600 square feet, and so we have that part now. Moving on to the bathroom, we have 10 feet by 5 feet, and so that's going to be 50 square feet. And then last but not least, the kitchen into the great room is 40 feet by 30 feet, which is 1,200 square feet. So the total square footage we can find by adding up all these numbers. So you take the 200 plus 200 plus 600 plus 50 plus 1,200. And what do we come up with? Well, that's 2,250 square feet. So what does that mean? Well, we want to find the price per square foot. What does that equal? Well, we have the house price. The house, so there's $247,300 per this one house. And then we want to figure out this price per square foot. So this one house has 2,250 square feet. So that's how you see your little conversion fraction. And so notice our houses will cancel and we're left with price in terms of dollars per square foot. So that means our price per square foot is $109 and 91 cents per square foot. And we just divided 247,300 by that 2,250. That's all we needed to do there. Okay, so what does that mean? Well, if you look, it was $120 per square foot is what the average home in the area sells for. So this price per square foot is less than $120 per square foot. So it's actually a better than average deal. So this is a good thing for Chandler and it makes it work out perfectly. So hopefully that makes sense in terms of how all this runs down. If you have any questions, once again, don't hesitate to ask.